Hi there, my name is Malcolm McMillan from Lancaster University, and this is a short poster presentation to introduce to you EO for SMB, which is Earth Observation for Surface Mass Balance. So EO for SMB is a 2-year feasibility study which has just kicked off last month. And is part of, or is a response to, the Polar Plus ITT theme for SMB feasibility work. So as such, it forms part of the ESA Polar Science Cluster. The project itself brings together a consortium led by Lancaster University and the UK Centre for Polar Observation and Modelling, with partners DTU Space, S&T, MVO, and also Shepherd Space. So the overarching aim of EO for SMB is really to try and demonstrate the feasibility of measuring ice sheet surface mass balance, or SMB, from space or from satellites. So here really we're focusing on trying to establish the foundations for a future operational surface mass balance product derived from space. So as such, this feasibility study is really focused on 3 key aspects. So firstly, the method development and optimization. So what are the methods and the algorithms that we need to use to be able to exploit satellite data for this purpose? Secondly, thorough and systematic validation and evaluation of our different techniques to really establish the fidelity of the methods and the products that we're developing. And finally, to demonstrate the worth or the value of these data through both scientific case studies and also scanning the horizon for future objectives and opportunities. So in terms of the specific objectives of this 2-year study, firstly, we aim to generate a prototype Earth observation product containing key SMB parameters. So as part of this scoping work, we'll prioritise certain parameters, we'll look at the maturity of different EO techniques, and we'll also consider exploring new exploratory approaches such as artificial intelligence and also joint inversions. We'll look to perform thorough validation of the datasets, the prototype datasets that we produce. We'll also look to demonstrate the scientific impact of these products. And lastly, but one of the most important aspects will be to define a scientific roadmap which really sets out the path or the vision towards future operational SMB products. So in terms of the methods that we'll use, we'll assess several EO methods to quantify a range of SMB parameters. So namely, we will look at surface mass balance, ablation rate, accumulation rate, runoff and mass accumulation. We'll also look at exploratory analysis using several newer techniques. So firstly, the testing approaches which look to use joint inversion methodology applied to multiple EO data sets, and we'll also look at the use of machine learning methods to enhance the amount of information that we can retrieve from lower level satellite data. So ultimately, I suppose the ambitions for the 2-year project are really to initiate or to catalyse a new era whereby we can operationally monitor surface mass balance from space, and to do this by demonstrating the feasibility of a future operational or thematic product dedicated to this area, and we'll aim to do that by producing a 10-year prototype product. Obviously, as we go, we'll systematically evaluate and optimize the processing algorithms that we develop, and alongside that we'll also look at higher risk exploratory methods such as joint inversions and AI. Ultimately though, we hope to initiate closer collaboration between EO and modelling communities, and to jointly develop a future roadmap which will set out how this feasibility study can be built upon in the future. So thank you very much for listening. If you're interested to find out more, then you're either welcome to contact me directly at m.mcmillan@lancaster.ac.uk or to visit our website. Thank you.